So I'm really excited to be hosting this session here today and continuing our conversation around what we need to do specifically in our homes and our buildings to start to cut down on carbon emissions associated with the power that we're using in a more creative way. And even if we're building and renovating to net zero standards, of course, that's weatherization, energy efficiency, electrification, right? Air source heat pumps, geothermal heat pump water heaters, and then solarization at the top. Even if we're doing all that, which we educate and talk about all the time constantly here today, of course, there's still going to be that carbon and energy being used in the summertime. You might be net zero all day long, but at night you might be pulling from the grid. And especially in the winter where I'm at in colder climates, we're pulling significant carbon from the grid. So no matter what we're doing, there's still carbon being used. And so there are some different ways to offset that. And that can sometimes lead to green building certification programs like LEED Zero or the NGBS Zero program or our program, or just wanting to do it because that's something you want to do as part of a funding strategy you have or an ESG strategy or just the right thing to do. So that's why I'm excited to have this conversation today and welcome McGee Young from Watt Carbon to talk about EACs and their unique approach to that. So McGee, welcome, and please take it away.
Thanks, Brett. I appreciate the intro, and it's great to be here with you and your group. Let me go into presentation mode. And slideshow. Assuming y'all can see this okay and hear me okay.
There it is, yeah.
Perfect. As Brett mentioned, I'm the founder and CEO of Watt Carbon. We're a national company, although I'm based out here in Lafayette, California. I'm a big fan of Brett's. We've known each other for a few years now. Prior to starting this company, I was the CTO at a company called Recurve. Recurve builds measurement verification software for demand-side energy programs, mostly for utilities, and also has developed and operates demand flexibility markets across the country. And I got started on this work really, coming out of the world of M&V. The questions that we asked there are some of the same questions that Brett was just alluding to, which is that if we're, generating a lot of solar in the daytime and maybe a lot of wind at nighttime, we really have to start being, thoughtful about, what are we trying to prioritize? If we're saving energy at the same time we're over-generating solar, which happens a lot out here in California right now, and maybe that's not quite as helpful as when the sun's not shining or the wind's not blowing, and really, as we think about buildings, this is kind of the linchpin of what should be, the linchpin of our climate strategy. 40% of emissions are traced back to buildings. This is the kind of work that we can do today that doesn't require any sort of like fancy new technology to be able to deploy. And so there's this, kind of a lot of the work that we've been doing collectively as a community has really become, risen to the forefront of actually, saving the planet. Brett mentioned that, there's a lot going into building performance standards, kind of, requirements around, net zero buildings that, in a lot of ways are trying to come at this from kind of a top-down approach. You have to install solar panels on new buildings in California. In New York City, there's, local law 97 that, sets a threshold for carbon emissions for buildings and then some steep penalties for exceeding that threshold. We kind of look at the opportunity in buildings a little bit differently as a way to create incentives and align incentives for decarbonizing buildings, more of a carrot than a stick approach. And the way that we kind of think about this is as an alternative to carbon offsets. where typically a carbon offset would be, a mitigation measure for emissions where you've already are emitting CO2, either directly or indirectly, and you're looking for solutions that would absorb that CO2 from the atmosphere, like a nature-based project where you would, plant trees, or even a science-based project where you would maybe capture that from the air and store it deep in the ground, or some other solution. Our kind of thinking on this is like, maybe we should just not emit the carbon in the first place. And if you have carbon emissions that you haven't been able to mitigate at this point, maybe the better solution, instead of just trying to soak them up from the atmosphere, is to actually try to decarbonize other buildings, achieve some sort of net, like literal net zero, by eliminating emissions that are happening in other buildings, and in doing so, maybe incentivizing more projects to happen, and creating more of a virtuous cycle where we're all collectively trying to eliminate our own footprints, but in doing so helping others achieve their own net zero goals. So I'm going to talk about that today, as the way that we've thought about creating the kind of like certificates that would be more familiar from carbon markets or from REC markets, but how we're taking those certificates and applying them to the work that goes into building decarbonization. So I want to start with this kind of like North Star question for us: why 24/7? And Brett alluded to this earlier, that it's not just about reducing your energy use. It's about the time of day in which the energy use is being reduced. As we think about the transition that needs to happen, is one to a completely carbon-free energy system. That's clean energy everywhere, 24 hours a day, 7 days a week, 365 days per year. It's happening again in places like California right now. We're over generating during the middle of the day with solar. We've got hydro reserves that we're turning off because we've got plenty of solar. But at the same time, our natural gas plants stay on for the better part of the day. In fact, they stay on all day, because in the evening when the sun goes down, we have to ramp those gas plants up. And so we're still not to the point yet where we can actually turn off our fossil fuel plants, and that's what's going to ultimately be needed. And in particular, the challenges are not necessarily the middle of the day or the middle of the night, where we're going to have plenty of sun in the middle of the day. We've got wind available to us at night, but really it's those early morning hours when we all get up and take a shower and turn on the heat and cook breakfast. And the same kind of thing happening in the end of the day too, where we come home, turn on the air conditioning, cook dinner, wash laundry. These times of peak demand, when we're using the most energy, also happen to coincide with the times of day which the sun's going down and the wind hasn't quite picked up yet. So renewables are at their minimum when our consumption is at its maximum. And so the challenge for us, like kind of in decarbonizing buildings, is how to align demand with renewable supply. What we're trying to do with the way that we've kind of designed Watt Carbon is allow us to meet peak demand with clean energy. And the question is, how do you do that, right? How do you align those incentives so that we're pushing demand into the times of day when there's ample clean energy, and then and maybe pulling some of that clean energy into those times of day which to meet that higher demand. What we need to do, like fundamentally, is rebuild our clean energy markets around a 24/7 framework. And what I mean by that is that if you go out and you try to buy a REC right now, that REC is going to reflect or represent a megawatt hour of clean energy, but not necessarily where it was made, what time of day that clean energy. So I could sign up, for example, today to PG&E's 100% solar clean energy plan, and they'd call me net zero, and that's silly, right? Because as far as I can tell, PG&E hasn't figured out how to make the solar panels work at night. And so what they're meaning is that they're using this kind of concept of clean energy, of a clean energy market that's independent of time. And we see this happening with companies where this is independent of space, where you buy a national green rec that fit more than 50% of which come from a wind farm in Texas or Oklahoma. And so you can buy this today for your building in Michigan and call yourself net zero. Well, this is sort of, missing the point of trying to buy clean energy, is that we want to achieve a decarbonized grid, and to do so on a 24/7 framework, within the grid in which your energy use is taking place. And so building new markets around this more kind of complex world, thinking about hourly, thinking about locational, encompassing both supply and demand. So it's not just about building more solar and wind, it's about building in energy efficiency, demand response, load shifting, the kinds of tools that we have at our disposal to be able to shift demand, to be able to match better to available renewable supply. So at a broad level, what this means is that we've got to reimagine our energy systems. We've got to think about distributed energy resources, about grid interactive demand, about inclusive energy markets. In the olden days, it was just, put up a power plant and send power out to meet the needs of the population. Now we have to think about distributed generation, where maybe that power plant is a heat pump in somebody's house, or a solar panel on somebody's roof, or a battery that's shifting load, or an EV charger. Whereas in the past, the grid, responsibility was delivering energy supply and keeping the lights on. Now the grid is responsible for orchestrating supply and demand. So how do we make our own demand side resources accessible to grid operators to help manage the supply and demand balance? And in the past, our rec markets, if you guys are in, where Brett's at, I think maybe MISO territory, maybe PJM, maybe actually Michigan, I think, has its own.
It is MISO, yeah.
It's MISO, okay. Well, in MISO, you mostly are focused on, your rec markets are focused on large scale wind and solar recs. But could we start to imagine a world in which, clean energy was valued not just as a megawatt hour of generation, but might include savings, might include demand response, might include other resources, might include energy efficiency. And if you could do all of that, could we, in fact, reimagine a clean energy procurement scenario that was inclusive both of demand side and supply side resources? We could have RECs for buildings, for example, and that's what Watt Carbon is trying to build. Okay, so how do we do this? One of the challenges that we've seen is that we're on about a 300-year time frame for decarbonizing buildings in this country, which is really problematic, since this is, again, 40% of emissions get traced back to buildings, and so we've got to figure out how to accelerate this in a significant way. One of the real limitations from a corporate side is that there's, in the world of what as you think about a corporate buyer is going to come in and maybe try to create a net zero framework for itself, it looks to protocols like the greenhouse gas protocols, the SBTI standards. It looks to carbon offset markets for guidance on how to mitigate their footprint, and almost entirely those existing protocols focus on nature-based offsets. And so when a corporate says, "Hey, I'd like to decarbonize buildings instead, I'd like to eliminate emissions," the existing frameworks kind of look at that and don't really know what to do with it. We don't have very good guidance for how to use buildings as offsets. Similarly, if you're a clean energy buyer, if you're a corporate that's trying to go net zero, if you're like an Amazon or a Google, you're mostly either limited to buying large supply contracts. So you see these announcements for these huge wind and solar buys that the big tech companies are able to execute, or you buy green recs. Again, more than half of those just come from wind farms in Texas and Oklahoma. So you're, in that sense, you're missing out on the opportunity to have an impact on building decarbonization by trying to procure clean energy or to buy offsets. So that's missing. From a building owner standpoint, there's not a lot of incentive to actually invest in decarbonization projects. If you're going to make an investment, you've got to make the energy savings pencil. And while that can happen, and that happens all the time, it raises the bar quite a bit for, what qualifies as a legitimate investment to make. And we see, every day people going, well, I think I'll just stick with the same gas furnace that I already have. In fact, we install 20,000 new gas furnaces per day in the United States. Every single day, 20,000 more gas furnaces and water heaters get installed in buildings because they just make more economic sense than switching over to a heat pump. And so as building owners, we're stuck between, making a better financial decision or saving the planet. And we really don't want that. We need some other incentive in place to be able to encourage building owners. And then if you're renting or leasing either residential or commercial, those lease structures make it really hard to justify investments into decarbonization. You just don't get the benefit from that as a renter. And obviously this leads to a split incentive problem between tenants and landlords. So every single building where you have that sort of relationship struggles. Maybe you can get a green lease signed. Those tend to be complicated and not all that impactful. And so this is why buildings are difficult to decarbonize. We just don't have great incentives in place to be able to push them across the line. One of the biggest barriers, and many of you have probably seen this firsthand, is the finance for distributed energy is it's kind of broken. When you look at what it costs to finance a project, the interest rates now are for consumers, even for businesses. If you need a financing, you're looking at mid-teens interest rates. And this is a thing that we worked on a lot at Watt Carbon, trying to figure out, like, why is this happening? Like, why is it so expensive? And what we realized is that banks have a really hard time underwriting clean energy projects. That there's this sort of, it's like a green premium that they assign because they look at it and they go, well, if I'm going to lend money for the solar panels or for this insulation or for this heat pump, and let's say the customer doesn't pay it back, am I supposed to like go repossess their insulation? Do I have to like go rip it out of their walls or something? Or so there's like this kind of hang up that banks have. They don't have great data on the effectiveness, and so they end up kind of throwing up their hands and just charging a lot of money instead. And so you get this kind of like high interest rate as a portion of the overall loan that ends up with a relatively high kind of annual rate for financing clean energy. And so what that means is that, like, let's say you're going to go put solar panels on your house or a heat pump, it's going to cost, roughly $20,000. If you can pay cash, then you pay $20,000. But if you have to take out a 10-year loan at 12%, all of a sudden now it's a $34,000 project. And if you have poor credit, that turns into something like a $43,000 project. And so what that means is that we're like more than doubling the cost of the clean energy transition for poor people relative to rich people. And to me, not only is this a crisis for our planet, but I think we have to look ourselves in the mirror and ask, why have we set up a system that fundamentally penalizes poor people for the same services that rich people get? And so this is part of the problem that we're trying to solve at Watt Carbon with the introduction of these energy attribute certificates. What we've realized is that, energy savings is carbon savings, right? The solution is right in front of us. And distributed energy resources, DERs, as we like to call them, at scale, we could reduce 30% of all of our carbon emissions by deploying DERs, batteries and smart thermostats and heat pumps and solar panels on our houses and all of the rest of these things that we know are out there, but we can't figure out how to pay for them effectively. So how would we do that? Like, how would we start to build a system that allowed us to value the environmental impacts of distributed energy? And so there's kind of three big pieces to this that we're missing, and this is what the market ends up needing to be able to grow around this. So first is a system of record. Like I mentioned, the carbon offset markets don't really provide a pathway for buildings to be included in carbon offsets. The REC markets are just megawatt hours of generation, and so that doesn't really work. So we need a system of record that actually works for distributed energy resources that can issue a REC-like certificate and allow for the non-energy claims to be made alongside of the energy claim. So if you have an environmental impact, if you have carbon savings, to be able to own that portion of the value stack independent of the energy savings that might have accompanied that project as well. Number two is a market. So like any, if you want buyers and sellers, you've got to allow them to come together, and buyers need a legitimate way to show their climate impact, and project developers need a way to monetize the non-energy benefits of their building decarbonization projects. It's got to be more than just the bill savings that you can bring to the market to convince consumers that this is a worthwhile undertaking. And of course, as I just mentioned, project finance is critical to this. If we still continue to ask people to pay 15% interest rates on these projects, they're just going to say no. There's no way around that. So we've got to figure out how to actually take the risk that we currently put on end customers and figure out another entity that can take on that risk, that can bring down that interest rate so that we're not asking people, especially poor people, to pay more for their decarbonization projects. So that's what we've built at Watt Carbon, is the first environmental attribute procurement platform, say that 5 times fast, procurement platform for distributed energy resources. What that means is that we're helping to unlock millions of dollars of investment into clean energy projects in local communities so that we can get rid of our reliance on fossil fuels. Like at the end of the day, we want to eliminate depending on fossil fuels to heat our buildings, to keep our lights on, to power our companies. And our goal is to really steer ultimately billions of dollars into clean energy investments into our communities, not just in the United States, but around the world. If you want to learn more about us, you can Google Watt Carbon, and some of these media articles will pop up and read all about us also on our blog, wattcarbon.com. Okay, that's enough about us. So what have we built now to enable this market to happen, this new finance to happen? We've built a distributed clean energy environmental attribute procurement system. And so what this means is that every net zero buyer, any company that's buying RECs, any company that wants to have a net zero goal for itself, any individual that says, you know what, I'm just not buying my utilities claims of clean energy. I'd like to make sure for myself that I'm actually netting out my carbon impacts. I can now procure the environmental attributes, the EACs associated with lots of different types of projects, solar panels, storage. If I'm in a commercial building and I want to have a better alternative to a green lease, electrification projects, infrastructure projects like upgrading electrical panels or installing EV chargers, social impact projects, trying to reach more LMI communities, enabling load shifting. All of these different types of projects have EACs associated with them, each EAC representing a watt hour, that's the energy in the EAC, the attributes being when did it take place, where did it take place, what type of system was it, what was the carbon impact of it. So you have a set of attributes that correspond to each unit of energy, and then it's in a certificate. It gets a serial number that is yours and yours only. So we don't have double counting. We can retire these formally against our net zero goals, and show off, to our auditors, to our other stakeholders, that we have in fact met our net zero goals and demonstrated the impact that we want to have in our local communities. We allow this purchasing to happen in 2 ways. One is through an on-demand marketplace where anybody can come in and buy and sell EACs, and then secondly through what we call environmental equity finance. This is similar in a way to tax equity finance, if you've run across that before, where me as maybe a homeowner I don't have, a need for to demonstrate net zero. I just want, lower bills. I want solar panels. That seems cool. And so I can sell the rights to the environmental attributes to a third party. Just like I might not need the tax equity that might, the investment tax credit or whatever that might come along with my battery. I just want a battery. So I'm willing to sell that to a third party who needs the tax break. I'm willing to sell it. Similarly, I'm willing to sell the environmental attributes to a third party who needs the credit. And in exchange, they help me pay for my project. And they get to claim additionality, they get to claim targeted impact, they get to recover to some extent their cash flows on the project. And so it becomes kind of a win-win situation for the end user as well as the procuring organization. So one of the things that we've built is a system of record. We call it WEATS, the Watt Carbon Energy Attribute Tracking System. And this has a marketplace attached to it. So this is coming next week for the most part. So you guys are getting a sneak preview. There's a little bit of a preliminary version of this marketplace available on our website right now. But if you check back next Tuesday, you'll see the full shebang. What this WEATS registry marketplace, though, allows for is hourly tracking of energy attributes anywhere in the world, inclusive of all types of resources, so both generation as well as savings or demand flexibility, heat pumps, electrification, and flexible attribute tracking, which meaning we can track attributes like deliverability. Is it in your same grid? Incrementality, was it a recent project? Temporality, what time did these savings happen? What was the carbon intensity? What were the social benefits? So that, as you think about this as a project developer, you think about what is the story that I can tell around my projects that I'm doing, and how can I help, kind of communicate that story to potential buyers who want to show that they're having an impact on helping these projects get off the ground. These are some of the partners that we've been working with, to date. This list is growing on a daily basis, but just kind of give you a sense of the range of different types of EACs that are being generated from distributed energy resources. The last thing I want to talk about before we get into the Q&A then is what this notion of environmental equity finance a little bit more. We call this a VPPA, which is another awful acronym because there's VPPs, which are virtual power plants, and then this VPPA is a virtual power purchase agreement. It comes out of the concept of a VPPA, comes out of the world of large wind and solar project development. And if you think about what happens there, you get like a company like Google or Microsoft that says, hey, we want to build 100 gigawatts of solar. A solar developer contracts with Google or Microsoft to do this, to do this project, but the solar developer needs to go to the bank and borrow money to be able to build the solar panels. Well, the bank comes back and says, how do I know that you're going to be able to repay this loan I'm going to provide you? And typically what you would have is the solar panel developer goes, well, we're going to sell this energy to the grid, and we're going to get paid by the grid for the solar power and the bank says, well, how much are you going to get paid? And the solar panel developer goes, well, we don't know because the price is always changing on the grid, so it's hard to say. And the bank says, well, I'm never going to lend you money for that. And so what Google or Microsoft will do is they'll come and they'll say, we'll guarantee a payment over a certain amount of time for the power that comes from this new solar facility, as long as we get the rights to the environmental attributes associated with that, and then we get to make up the difference in the cost by selling the power back to the grid ourselves. And so that's why it's a power purchase agreement, but it's virtual because they don't actually take the power themselves, right? The power gets just sold back into the grid. The important thing that happens is that the risk of repayment shifts from the solar developer to Google or to Microsoft or whoever the off-taker is. That's the really important part. And Google, for the most part, again, or whoever the off-taker is, can recoup the cost of purchasing that power. They'll typically try to purchase that power at a lower rate than they can sell it back to the grid. So they end up making money on the project and getting to net zero. And we've built more solar that we don't have to now use natural gas or coal to power the grid with. It's a win-win-win situation. So for CFOs, they like this because at the end of the day, it's kind of cash flow positive. You get the both recoup your initial and financial investment, but also get the clean energy credits and the tax credits. For sustainability directors, they love this because it meets the addition, all the like rules of carbon accounting, additionality, etc. You get a lot of impact with it, and it's simple. And so whereas that's a fairly common practice for big wind and solar projects, what we've done is figured out how to do this for distributed energy projects, for rooftop solar, for energy efficiency, for demand response. And what this means, going back to this kind of like problem of how do we fix clean energy finance, kind of recentering this question a little bit, what we've done is we've said, okay, it's not quite the same as like building solar and like selling it back into the grid. The risk is a little bit different. The risk is this in this green premium over here, right? This 18% where the bank says, well, are we supposed to like come take your solar panels off or something? They're like, whatever, we're just going to charge you a lot of money. We come in and say, okay, well, we're gonna sell the rights to the energy attributes. It's like the naming rights to a stadium or something like that, right? Like you're gonna get all of the energy attributes that come off of this project for the next 10 years. And we're going to sell it to you for whatever this premium cost would have been. And it's about 30% of the project typically is in this premium area. And so we're going to sell those energy attribute rights to the corporate off-taker and replace this 18% interest with a 0% interest loan. And we combine this with like the normal debt that happens with a project, which is like kind of market rate, but it turns the loan from the customer from a 12% down to a 5%. Even we can get it down to maybe 4%. And so all of a sudden, by selling the rights to the energy attributes ahead of time, we can cut the cost of financing in half for consumers. That is how we're going to be able to scale distributed energy resources, is by making it a cost-effective way to deploy, giving corporations the credit, as it were, for making it happen, which is what they're looking for, but ultimately making this a good deal for consumers and making it easy for them to say yes to these projects. Now, the last thing I want to touch on here before we open it up for Q&A is we've built all of this on open source architecture. So I think this was really important to the market, is that, how do I know if these EACs are real? How do I know if I can trust this? The way in which a lot of existing carbon markets work is that you go hire expensive consultants. And for those of us who are in this industry know, like, we can end up spending a lot of money on M&V if we're not careful. And that tends to, eliminate a lot of the savings because you're spending all of your money on M&V. And so we wanted to make sure that every single EAC that's generated through and registered into WEETS has been verified and validated through an open source process, through community oversight. And so we've built what we call the Open EAC Alliance, which is an organization comprised, mainly of companies that are trying to generate EACs, measurement and verification professionals who care deeply about the validity of savings calculations, and are actually tomorrow having a kickoff call to kind of showcase how we're making the methodologies and the data science, as it were, visible through this kind of open source process, so that anybody who ever wants to buy an EAC or sell an EAC can click through to see exactly the methodology that generated that attribute in the first place. So if this is interesting to any of you, check out openeac.org. If you'd like to get involved, either to sell EACs, to participate in the Open EAC Alliance, George at wattcarbon.com is the place to go. And if you'd like to learn more, I know this is going to be a little bit tricky if you want to screenshot it and type it in or something like this, but this is the main repository where all of the methodologies are being held that describe how each of the EACs is calculated. And with that, I'd like to toss it back over to you, Brett. We've got a little time for Q&A here, and open up the conversation a little bit.
Yeah, thanks, McGee. And yeah, we do have some time, and we've got some questions that are coming in right now. And real quick, before we get to those questions, just a reminder that yes, this session is being recorded, and so you can check it out on our YouTube channel if you want to rewatch it. Post it on social media. We love when you all share it. Send it to a friend or a colleague, or just kind of catch back up on anything you might have missed. You can go to our YouTube channel right now. You can hit subscribe. You'll get instant access when it's available, or check back later in the next couple of days to have it. And again, as we're waiting for those questions to come in, just a real quick reminder, for those of you watching this on demand, not right now, head over to take your quiz with an 80% passing rate, and you'll receive your continuing ed certificates. For those of you here today, check over the next couple of days your email from certs@gutenbergcerts.com. You'll receive your certificate as long as you've been here the entire CEU approved hour. And make sure to take that survey that pops up at the end. And before we get into the questions, again, just a huge thanks to our board of directors, our volunteers, our executive director, Jose Reyna, our nearly over 300 members who support our work, and all of our sponsors, especially our top tier platinum sponsors, Rheem and Mitsubishi, who are making these decarbonization projects, right? Who can then be connected to the energy attribute certificates. So it's all connected, right? And so, yeah, you know, one of the first thoughts I had, McGee, and I think you kind of started alluding to it, but just to sort of clarify, is this concern about double counting. And I'm thinking, you know, on maybe on the demand response items, and probably on the decarbonization items, the sort of electrification items, no one's doing that, right? So having a double counting there, at least for now, probably not a problem. So that's great. But on the solar and wind projects, even some of the smaller ones, I understand, right, can you know, generate RECs. So my question is, are you, when someone's registering, is there a mechanism that's checking any of these other green ERECs, and vice versa? Are they also checking to make sure someone's not showing up on your platform? And what's your thoughts on that?
Yeah, I think it's really important that we avoid double counting. So part of the registry that we built, one of the kind of core pieces of it is a concept we call interoperability, where you need to be able to check against our registry if you're registering with if you're another entity, and that needs to be reciprocal, right? So if we say, like when we work with Solar Hauler in West Virginia, some of their RECs automatically get minted as part of PJM GATS. So we go in and actually, when they sell on our marketplace, we retire them on PJM GATS and reissue them through our registry. Their megawatt hours on GATS and their individual watt hours on our registry. So which is why we have to retire them on one, recreate them on the next one on ours. Mm-hmm. And then each individual watt hour gets its own unique serial number, but all of those serial numbers get tracked back to the original REC that was issued on PJM GATS. So you have that kind of full life cycle of like, where did this come from? This is a very important part of the legitimacy of one of these systems. And we take that very seriously. There are others who don't take it so seriously. And so, for example, a lot of utilities, when you get a rebate for, you know, a program that you participate in, they'll bury in, like the fine print, footnote 6 or whatever, that part of taking the rebate means that you've given up all your rights to the environmental attributes, but they don't really communicate that to you. They don't post that anywhere. They don't even necessarily like pay you for that.
Mhm.
And so one of the things that I think is important for all of us is to demand greater transparency from our utilities and our utility programs, and to know exactly, how and whether they're including the rights to the environmental attributes as part of the rebates, so that we don't have the situation where, like, unbeknownst to all of us, they've squirreled them away somewhere, or they're using it to meet their own RPS goals, and we don't know about it. We need, to make sure that the entire industry is operating in a more transparent fashion.
Mhm. Mhm. Um, so a couple other question coming in here. One of them, was just looking at sort of our new construction friends, and please, to whoever, to ask the question, if I didn't quite say it right, feel free to chime in again. But I'm curious about it too. So I think of, you're building a new construction project, and so I'm going to elaborate on their question a little bit. But that was, they were looking at sort of that we do this energy modeling, right? And we say it's sort of a, why guess when you can know. So we can forecast to some extent with some, what I would call very good accuracy, depending on if you've got a good energy modeler and a good team put together, what energy usage is going to be, at least for the years and the month. Some of these programs now are even getting down to hourly ratings, and they can forecast that to some extent. And so I think, if I understand their question correctly, it's just like, have you thought through the process on the new construction side, whereby you might have those models completed, and then you go and say, all right, we understand there's a deficiency on the grid. We can't do anything about that. It's one building, we can only do so much, but we can get the rest from these EACs. Have you seen any collaboration like that, or anything emerging in that area?
Yeah, I think two important points there. One is that, that methodology, if you asked 10 energy modelers to come up with what the counterfactual would have been for that
Sure.
new construction, you get 10 different answers, and they're all right.
Right.
So part of the Open EAC, the purpose of the Open EAC Alliance is to require the methodology to be published for how you would calculate what the usage of the building would have been if, for example, it had been built to code,
Right.
right? But let's say you're doing passive house and you're 75% below code. That's a lot more expensive, and it may be a kind of a hard, sell to the end customer, unless, it's like people like us who are like, yeah, I'll do it anyway, right? But if you're an end customer and you're
Mm,
like, that's a lot of money,
mm,
now
mm.
we can use the EAC to help, offset some of the cost of going the additional mile. And but we want to know, like, on what basis are you making that claim for this is lower energy use than it would have been if it had been built to code? And that's where the transparency of the modeling comes into play. And so we definitely know that there's going to be some discretion that happens, some choices get made, which, models that you end up using. So as long as you can bring that to the kind of the group, right, your peers, who can evaluate that, and you can get three of them to sign off on, that this is a legitimate representation of the energy use that would have happened if it hadn't been built to this, deeper level, then um, then that can get, certified as an official methodology, and and those EACs can, so then you have transparency and visibility from the
Mhm.
EAC side in terms of the assumptions that were made around, that kilowatt hour or that watt hour that you're tracking.
Mhm. Um, another question that came in here is, it's gone. There it is. So is there granularity in the tracking? For example, could you verify that you're purchasing offsets that occur during all hours of the day, not just during excess midday production. And, I kind of, to add to that, I think of like the duck curve or whatever that is now in California, where are you just buying things that are just fully like deepening that canyon, which may
Hmm.
not be needed, if I just add some context to that conversation, but truly when the power is actually needed.
Totally. So each attribute, each certificate corresponds to an individual watt hour.
Hmm.
And so, and you can imagine that, that ends up being a lot of certificates. So we kind of bundle them all together.
Yeah.
But each watt hour happens at a particular time of day. And so you can say like, I just need some like 6 to 8 p.m., certificates, and I can filter for just those resources that are online between 6 and 8 p.m. And so now as I'm thinking about buying, I might just want to go focus on, maybe batteries, maybe load shifting, the types of things that happen during that time of day. Whereas though, if I'm in, say, Michigan, where there's not a lot of solar yet, I might be okay with middle of the day because, in a place like Michigan, that still is going to have a big impact relative to the other resources that are available. And so it's not just the time of day, but also the location that really determines, kind of the impact that you might have with a particular purchase. But for sure, that granularity is core to the entire effort that we're trying to unlock here.
Yeah. And so another question that came in, and I think you answered it, but just maybe hit on the point again here, is that you're tracking in these watt hours. You're not necessarily tracking in units of carbon, but that is a derivative that's communicated somehow, or how does that work?
Yeah, so we realized that it could get kind of complicated and messy to track in units of carbon. This is how the like offsets work, and it tends to encourage some bad behavior and then it's not always clear exactly like what that unit of carbon should be. Some people want to, use an average emissions number. Some you want to use the marginal emissions number. Some want to use an annual emissions number. Like so that in and of itself is a bit of a contested space. And so we thought the better thing to do here is to just identify the watt hour. That's kind of unambiguous, right? It is just a watt hour, and it will have a carbon attribute or several carbon attributes associated with it. And so then if you want to kind of aggregate based on carbon, you could actually go select, again, this is sort of thinking about this from a search for your attributes that you care about. You might try to identify or prioritize uh, pounds of CO2 per watt hour, right? And so then you could find what watt hours corresponded to the most carbon intensive times a day, the largest carbon impacts, and you might just want to buy those watt hours. Or you might want to go the other direction and just buy the least carbon intensive, like, whatever. But it allows you, but not everybody cares about that, right? Some people, like a company like Google has announced that it's mostly concerned with matching the time of day 24/7 to their location. For green hydrogen, to qualify for the green hydrogen credit, you have to be matching on the time of day and the location. And so in those cases, the carbon metric is unimportant to the purchasing decision. And so I think it's important, what we've kind of realized is that there's lots of attributes that matter, and to give consumers kind of the choice in which attributes that they want to prioritize when they make their purchasing decisions.
Mm-hmm. Well, and so I think this segues into something I wanted to bring up, and this is really how we ended up collaborating with you, because you're talking about when we're making these purchases, right? And so this is a great tool that you all have available that I've always found very helpful over the last, I don't know, I think since late 2022, I've been using it, where people can go in, or companies can go in and put in their energy data, assuming that they have a way to capture it through like a battery usually captures data down to the hour, or if your utility company allows you to print your green, I think it's called green button data, right? So our
Yeah.
utility, consumers energy, I can find my green button data, it's all there, and I upload it here, solar data. And what's really cool about this is, again, it kind of back to that question is, when would I be purchasing power? And I like how you can kind of see, get a sense for how carbon free you might be at certain times of the day or certain seasons of the year even. I'm kind of zoomed in here, so it's kind of smashed all together. But, and then of course what my grid mix was. And of course this is always a snapshot in hindsight, but I'd assume, it gives you a sense moving forward. And so I'm just showing that because, I'm even personally looking at this and encouraging others to look at it and go, oh, if I'm trying to offset my 2023 and be zero carbon for 2023, I've got, 58% that I need to offset. And then the other question is, when is it at? Well, it's probably not, in the middle of the summer when I'm sending solar back to the grid, because I'm doing that quite frequently. And so somebody with solar might be doing that too. So anyway, just kind of bringing that up in the context of, I found it to be a helpful tool for really dialing in on that, and maybe others might as well. And I don't know if you have anything to add to that, McGee. So
I think it was really illuminating for me, to just like when we built this for the first time, it was like this aha moment where like you just like kind of don't know, like this should be on our utility bill, I feel like, right?
yeah.
Like we should have visibility into what's going on. I was struck by, we've got 13% nuclear in this grid. There's some grids that have a higher percentage of nuclear power that on average tend to be a lot cleaner, carbon wise, than non-nuclear. So that was, I had, kind of had a bias against nuclear power, probably going back a long time, and just not really thinking about it from a carbon standpoint, but how clear it was, like, that coal, that 25% coal really makes a big difference. And some grids have mostly cut down on the coal and replaced it with nuclear. Wind and solar tend to complement each other really nicely. Is another kind of thing that I've noticed, that the wind tends to be more available at night, solar during the day. So grids that have high penetration of wind resources tend to be cleaner at night. Texas is a really good example of this. And so you'd want to kind of change how you think about your own, strategy based on what the makeup of the grid is. Where it's a dirty grid like this one, heat pumps right now are a little harder to, the carbon impact of a heat pump is still there, but it's not quite as strong as in a grid that's fully decarbonized, like what you get in the Pacific Northwest. So I think this just helps you think in a little bit more of a sophisticated fashion about, like, how do you maximize your impacts given the situation in which you're using energy in the first place.
Now, another reason I definitely got excited, originally when we were reaching out to you, is initiative we started quite some time ago, where again, we were kind of looking at this from, like, especially from affordable housing or even a builder, like, as you mentioned, you're doing that net zero design and you're trying to fund some of this above code infrastructure improvement in a home or set of track homes or even a multifamily building, right? And it's always a struggle. You pointed out the issues with financing. Someone in the comments said, inflation, costs are up. It costs more to borrow. I know when I did my project in the height of the pandemic, interest rates were collapsed and it was a great time to borrow. And now that isn't the case anymore. And it probably won't be for a long time from, like, the lending standpoint. So where I'm getting at is, what we were looking at quite some time ago was just like saying, hey, what if we had like 50 homes, people who are experiencing poverty, let's get them, some upgraded infrastructure, some heat pump water heaters, and what is the value of that, right? And we went out and tried to figure out how to get it in the Rex market, and it's like it would cost 4 times the cost of buying that water heater to get the water heater certified in the Rex. I don't know the exact number. I'm kind of being a little bit joking a little bit, but it was an extreme amount, and the process and effort, it was just crazy. So I got real excited when I met you and talked about this program. And so how does that work? Let's say you're an affordable housing agency, you're improving all these homes. it's like, hey, it's going to cost me $6,000 for a water heater. And maybe some of it comes from the utility company, but I still have this remaining amount. The reason I'm kind of asking this is one of the attendees asked this a question: what are the prices we can get, right? But instead of asking what is the price we can get, which I believe the answer is all over the board, I want to ask it more in the context of like, how much can we chip away of the cost, and how big of a scale does that need to be? Could it be 5 water heaters? You have 5 homes coming up. Does it have to be 100, 200, 5,000? Can you give us some answers on that?
Totally. We've got a couple of really interesting projects along these lines that we're working on. One of them is a manufactured homes project, which tends to be a little bit more low income and hard to decarbonize in a lot of ways. And so what we've done is partnered. We're working on partnering with the city that's trying to help reach these customers and local businesses in the area that are willing to kind of help underwrite the costs. And in some cases, it's just a kind of a pay for performance model where like the more emission reductions that you can generate through these projects, the more the company will chip in and they're buying the rights to the environmental attributes, right? So they want to claim the net zero and they want to do it based on performance. So you go out there and we can do maybe $100 a ton. And the more of those that you deliver, the more reductions you can deliver, the more that money is going to get dispersed. That's useful, but maybe not the most impactful, because that's just like another form of a rebate that's now coming from the private sector. Where it's really useful is where you have an expectation of repayment. So maybe it's not, the just sort of like, hey, here's some, lower cost, right? It's like that interest rate that we were looking at earlier was like, that's the real barrier, right? Like you're asking somebody to put it on their personal credit and their credit score is not great. They're going to just get charged an arm and a leg. And so now we're saying to the community, to that corporate, hey, don't just provide another subsidy. Let's actually like help backstop the risk on the financing and take that risk away so that the bank, when the bank is making this loan, they're not making against the risk of the customer repaying. The customer still has to repay and there's still sort of the same protections in place, but the way that we underwrite this is different. And so now you need a little bit more size to be able to do this, right? Because you need a little bit more of like a portfolio approach to be able to manage your risks. But if you can increase the size a little bit, so maybe it's 50, maybe it's 100 homes, now we're really starting to get to the point where we can create leverage. So that instead of just one and two rebates here and there, now at a community scale we can start to really invest in decarbonization, and that's a situation where the corporate partner can really have an outsized impact because they can eliminate much of the financing costs by purchasing the rights to those environmental attributes ahead of time.
Yeah, that makes sense. And then another kind of question, some of the questions came in, they were just, hey, I've got solar and I know that the offset, there's an offset. I believe this person doesn't think it's claimed, right? Or the rec isn't claimed, or someone's like, hey, I'm doing events, I'm powering it with solar, or whatever, and it's making sure that the event I'm doing is reduce energy. Is there value to that? Can I sell that? Like, what about these really tiny projects? Can they get listed and sold?
Yeah, so we're working right now on an integration, several integrations with solar inverter companies. So if you think about when you put your solar panels on, there's that box on the side of your building that takes the power, turns it from DC to AC, I think, and so and if it's maybe in phase or solar edge, there's a handful of these. Um, they collect that data of your production of your solar panels, right, on an hour by hour basis, really like on a minute by minute basis, but we roll it up. And so we can take that data from in phase and turn that into EACs.
Mm-hmm.
And so what we're doing is working on like a kind of a two-step process for anybody who has solar panels who has one of these inverters to be able to register them in WEETs, start generating the EACs, and then because those are integrated with the marketplace, they can just take those EACs and flip them over into the marketplace and sell them again at whatever price that they feel like they can that they can get for them.
Yeah. Um, and then I know this is a little off of the topic and more carbon related, but I thought maybe you heard of something or aware of in the space. But there's obviously there's a huge shift now in the built environment to the embodied carbon or upfront carbon of products, right? So we go to put a product in a home, or renovate a home, and people are really concerned about that, carbon or energy that was generated to do that. Have you seen anything out there that is providing offsets? I know that obviously the big push right now is just to measure it, find things that reduce it. That's clear. But have you seen like a offset conversation around that?
Starting to.
Yeah.
It's very, very nascent,
Mm-hmm.
of course, right? As all of this
Right.
is. I see it. Um, mostly there's some work that's being done. It's not quite the same, but it's like refrigerant disposal. So
Mm-hmm.
rather than like kind of venting refrigerants like from a air conditioning system into the atmosphere, which is really, really bad,
Right.
disposing of that properly makes a big impact. So it's not quite the same, but it's along the same lines. And I've seen actually in commercial real estate where their developer is using kind of low, carbon emission products and actually selling the environmental attributes from that to the tenants
Mm-hmm.
who are coming in and leasing the space
Mm-hmm.
as part of the kind of like logic behind, you're paying a little extra. We want to get paid extra for the environmental attributes of this space. We can't really charge you extra on your rent, but if you'd like to be able to claim the environmental benefits, we can sell you the attributes. So it helps kind of overcome the split incentive problem for building materials at the same time. So those are what I've seen thus far, but I think that there's probably a lot of interest generally in kind of exploring how the embodied carbon can be lowered, obviously, but then also monetized and valued.
Sure, sure. Um, well, we're at the end of our session. I don't see any other questions and want to get this session wrapped up. So where, just remind everybody, can people go to contact you or learn more, get involved?
Yeah, for sure. Send me an email or George. George is the better person to send an email to be quite honest. WattCarbon.com. In 6 days, we're going to have the new version of our marketplace up. So next Tuesday, we're launching. It's going to be a really exciting way to see, kind of close up how all these different companies that I had listed on that slide we're partnering with, and they're able to sell their EACs now. So it gives, I think, a very great look at what's possible. And anybody here who's interested, we'd love to work with you.
Great. McGee Young, founder and CEO, Watt Carbon. Go check it out, McGee. It's good to see you. I appreciate you doing this and your time. And thank you all for joining us. And we'll catch you on the session next week. So take care. Goodbye. Be well, everyone.
Thanks, Brett.